This is assignment number 4, linear correlation. The problem to work through today is as follows. Model A shows that weight is equal to 3.8 times height minus 124 with an R squared of 0.87. What weight does it predict for someone whose height is 64? And how confident are you in this answer? The other problem is model B shows that weight is equal to 3.8 times height minus 124 with an R squared of 0.10. What weight does it predict for someone whose height is 64? How confident are you in this answer? And what units did the researcher most likely use? So first we should discuss R squared, the coefficient of determination, which is the correlation coefficient squared. It's used to find how much of one variable is explained by the variance in the other variable. The coefficient of determination is always a positive number, and its general rule is as follows. R squared less than 0.5 is a weak correlation. R squared less than or equal to 0.5 or greater than 0.8 is a moderate correlation. And then R squared greater than or equal to 0.8 is a strong correlation.
For model A, to find the weight, we multiply 3.8 by the height, which in this case is 64, and we subtract that number by 124, where we will get 119.2. Our R squared value will be 0.87, which is over 0.8, which means that it is a strong correlation. Therefore, if we have the strong correlation of an R squared value of over 0.8, we can say that we have a high confidence in our answer, and that the variance in weight can be explained by the variance in height.
Model B, weight is 3.8 times height, subtract 194. That gives us a weight of 119.2. So R2 equals 0.1, which is less than 0.5, indicating weak correlation. Meaning we have a weak confidence in the answer as R2 is 0.1. This tells us that the weak correlation between weight and height, meaning that only 10% of the variance in height is explained by variance in weight.
The units of measurements used in this question for weight and height are most likely in pounds and inches, respectively. For weight, 119.2 grams would be too light and 119.2 kilograms would be too heavy. And for height, 64 centimeters would be too short and 64 meters would be too tall.